Part 2 of our truss analysis on this truss. 5 members, AB, AC, BC, CD, and BD. A pin at D, a roller at B, and a 3000 load downward at A. Just to review, let's use red here. We did found the external. We found the external forces dy and dx. It ended up dx being 0. dy is negative 2,000 or 2,000 pounds down because by is 5,000 lb up. This was in the part 1 video. We found these numbers using the external forces method of solving it, moments about point D, and then you do the algebra, and then you solve for by. This got you to by. I think the math was 3,000 times 20 equals y times 12. Y equals 5,000 lb. Y forces up equals down. by plus dy equals down 3,000 from that 3,000 load over there. Plug in this by here, 5,000 or dy equals 2,000 lb down. This is a good answer. Then left equals right. 0 arrows are going to the left. The pin reaction at dx is to the right. So dx is 0 pounds. Then if you watch the other tutorial videos, we solved for 4 of the 5 member forces so far. So how does that look? Let's try and use blue here. That one, okay. We said CD is 3124 tension. So this member is 3124 lb tension. BD is 2400 compression. CB, this is on the previous tutorial videos, 5,000 pounds compression. It's getting compressed because by is pushing up on it and kind of this 3,000 pounds is squeezing it together. So here I could write down 5,000 lb compression. And then since this is 2400 compression towards pin B, AB is also 2400 lb compression. This is kind of how it looks. When you do it. So we've solved for all but AC. We solved for this one, this one, this one, this one. We have to do this one. We probably have to do method of joints on joint A. So how will that look? Joint A. So we're on joint A right here. First thing you have to do is draw a free body diagram. remember, you should always have this picture as your reference. We know the angle is 51.34. So let's see what we do here. Free body diagram. This is joint A. A 3,000-pound object is hanging down from the end of the truss at joint A, exactly down. AC, this is joint A, AC, assume tension, AC, and this angle is 51.34 degrees. Okay. And then, since we know from the previous problem that AB is compression, you draw towards, because towards the pin is compression, away is tension. But since we know this is compression, you put 2400 towards the pin. In method of joints, away is tension, towards is compression. It's just something you have to know. So now we could do our vector table. Vector, x component, y component. So there's three vectors here. 1, 2, 3. And the sum of its statics equals 0. Okay. So the first vector let's look at is the down vector at 3,000. The x component is 0. The y component is negative 3,000. You need to hold a sign. I mean positive or negative sign. The red vector, that's AB. It goes to the left at 2,400. So what does that mean? The x component is negative 2,400. It goes up and down 0. Okay, the last vector is AC, because there's three vectors in this picture. It goes up and to the right. The x component is AC cosine. Remember, x is always cosine. The vector, the angle, when it touches the horizontal from the given data, is 51.34 degrees. Cosine, oops. And then the y component is AC sine 51.34. Okay. Both columns have one unknown. The one unknown is AC right here. AC is the unknown. So let's just use the x column to solve for this. So let's do x column. Sum up all these, it equals 0. Negative 2,400 plus AC cosine 51.34 equals 0. Now this is single variable algebra. Add 2,400 to both sides. 0. AC equal, I messed up. Take this a step at a time. AC times cosine 51.34 equals positive 2,400 on this side. Now, to solve for AC, this is multiplication here. You divide both sides by cosine 51.34. It's your advantage if you have a TI-84, TI-83 calculator in this class. Oops, 51.34 degrees. cosine 51.34 divided by cosine 51.34 equals 1. So you get 1 AC equals, use your calculator here, 2400 divided by cosine 51.34, 3842. 3842. You can round to the nearest pound, it's all good. 3842 LB, since it's positive, put a tension sign there. So from the 2 videos, we have solved for all 5 members. Let's just sum it up over here. AB from the previous work is 2400 compression. 2400 pounds compression. AD there is no AD. That should be AC. I'm sorry, AC. So I'll just scratch this out. AC equals what we just found. AC is up here. AC is 3842. AC is 3842. Pounds, oh my god, equals 3842. I don't know what's going on. It's just erasing. Pounds in tension. BC, 5,000 pounds compression. BD, 2400 lb compression. I don't know why it keeps erasing. This is kind of odd. It's a little clear. Whoa. It's like a vanishing act. Stay. And then CD, 3124. Tension. So let's start from the bottom. We started at joint D. We solved for 31 CDs, 3,124 pounds in tension. And we solved for BD, which is 2,400 pounds in compression. And then we moved on to joint B. Joint B, all the vectors were either vertical or horizontal, so that was an easy analysis, relatively easy. CB is 5,000 pounds compression. I would watch the part 1 video for joint D and B. And then we also solved for AB, which is 2,400 pounds in compression. AC we did in this video because we analyzed joint A, method of joints, 3,842 pounds in tension. So now you have the 5 internal member forces for this video. Congratulations.